You should know all three of them by heart by now. The first one is that an object will remain at rest or travel with a constant velocity if the net force acting on the object is zero. The second one is essentially stating that there is an inverse relationship between acceleration and mass. And the third law is stating that if an object A exerts a force on object B, then object B will exert an equal and opposite force on object A. Note that these forces act on different objects, right? So this is referring to action-reaction force pairs. We will cover that as well. Don't worry, a lot of my students who did very well, a lot of them were really bad at physics initially. They couldn't get one question right, and then they ended up with a 40 plus study score. So it's pretty cool. You guys are gonna be fine. Trust me when I say this. I'm not just saying it to make you guys feel better about yourself. I'm genuinely saying it because I know physics is the kind of subject that anyone can do very well in. Anyone without exception. If they put in the right work. Because it's not about only working hard, it's about being smart in the way you work. I'll plug in my laptop before it runs out of battery. Damn, today is, it seems like a rainy day, at least in my area. Alright, so let's talk about motion a bit. Let's get more into it. These formulas are not, these formulas are on the end of the year formula sheet, so you don't really need to have them on your cheat sheet. And obviously, there are a lot of things that you can or cannot have on your cheat sheet. I have a lot of tips for that as well. But yeah, if we have time, I can cover those tips. So, with these formulas are for constant acceleration. Where S stands for displacement and is measured in meters, U is referring to initial velocity, V is referring to final velocity, A is referring to acceleration, and T is referring to time. So here, what I would say you need to do is that you need to it's really important. These constant acceleration formulas are really important, especially for projectile motion. But you guys need to understand something. When acceleration is equal to 0, right? The only formula that you need to use is essentially v is equal to x divided by change in time. Whereas when acceleration is equal to a particular value and it's a constant, you can use any of the formulas that you saw there. Primarily, you can use v is equal to u plus at. You can use v squared is equal to u squared plus 2ax. Out of those 5, these are the most common, and ut plus at squared on 2, right? Now, if we're together, I can cover again these concepts in more. If you were to have tutoring with me, private tutoring with me, particularly, I'm definitely not gonna cover this here in this lecture. Obviously, I'm gonna give you guys some tips about the cheat sheet and everything. I mean, we do have a separate subsection for this lecture for tips and stuff. But for the more in-depth kind of thing, for example, if a displacement time graph looks like an exponential graph, then the velocity time graph is linear, and then the acceleration time graph is gonna be a constant, right? And how they relate to these formulas, and so on and so forth, and then how to essentially use that to your advantage on an exam, and how those interrelate between concepts. I genuinely don't have enough time to cover it in this lecture. I would love to, But if you need to know more about that, if you're very curious, you can contact David, and he will essentially either book a session with me or with another tutor. You can just try it out, and you can ask them about this. Most of us, as I said, we've gotten very, very decent scores overall, so most of us know. As I said, we all have followed the same strategies, and we all know the same shortcuts, if that makes any sense. So yeah, I highly recommend paying attention, basically. Yep, so that's about it when it comes to acceleration. So let's get more into projectile motion. And I love projectile motion, I genuinely do. It's, I think, cool because it relates, it's multiple concepts basically that can be tested at the same time. With projectile motion, they can test you about Newton's laws, they can test you about momentum, they can test you about impulse, they can test you obviously about motion, constant acceleration formulas, and without any acceleration formulas. It's a pretty good topic to essentially tackle many concepts and theories. And this is why projectile motion questions have a lot of marks. They carry a lot of marks on the final VCE exam. A lot. When I mean a lot, I mean a lot. This can make the difference between getting you into the 40s and below 40s. Projectile motion is, the reason for that is because projectile motion is looking at a motion in 2D, in 2 dimensions. And remember that velocity is also a vector, right? And it can be split into its components due to its vector addition nature. So there are 2 components that can be treated individually, a horizontal component of velocity and a vertical component of velocity. They can be found from using trigonometry. And another important note is that the only force acting on this object in the projectile is gravity. So let me cover this again. Let me repeat it again, but let me simplify it a bit. What is a projectile to begin with? A projectile is essentially when we shoot something in a particular trajectory, right? When something is launched in a particular trajectory, for example, a rocket, right? Now, obviously, what will happen is that when you throw a ball, not a rocket, let's say a ball, when you kick a ball and it's going to follow a particular trajectory, the only force that is acting on the ball throughout its entire path, throughout the entire time it is in air, the only force acting on the object, on the ball, is going to be the weight force. Obviously, there's also air resistance that comes into play, but don't forget, the VCAT study design says that you only need to understand, or you only need to give a qualitative response in terms of the effect of air resistance on the projectile, right? So no quantitative nature associated to it. But let's focus on the other components before we go to air resistance and discussing about that. So what are the components of a projectile? We said that the only force acting on it is going to be the weight force. What else? Well, the projectile looks like an inverse parabola, alright? And we know that another component of the projectile is going to be its height and its range, because as we said, it's 2D, right? It has both a height and width. Now, this is really crucial, alright, and we're gonna come back to it later, for the height and the range of the projectile, right? This is what we call, the range is the distance from point A to point B, and height is essentially how high above the ground, if this is the ground level, does the projectile go. Now, the object will have obviously only a force acting downwards on it, but it will have a velocity, and the velocity will be at a particular angle. Now, if you do remember from year 11 physics, we have talked about scalars and vectors. Scalars are variables that only have a magnitude, for example, distance or time, whereas vectors, they have both a magnitude and a direction, for example, displacement or velocity. Speed is a scalar because speed is equal to change in distance, right? Change in distance over change in time. That is what speed is. Velocity, however, it's defined in terms of displacement. So because displacement is a vector, velocity is also a vector. But what is displacement? What is the difference between displacement and velocity? And the reason we need to know that is because acceleration is equal to change in velocity over change in time. And that is why acceleration is a vector, because velocity is a vector. But velocity is a vector because displacement is a vector. But what is the difference between displacement and distance. And the difference is very simple. Let's take an example to understand this. Let's say there is a frog at the bottom of the wall, and the wall is 5 meters. This frog will try and climb over the wall. It will try and go to the top once, but then it will slip back down, and it will try and climb it up again. The distance that the frog has covered is actually 15 meters, because the frog has gone up, down, up, right? 5 meters up, 5 meters down, and then 5 meters up again. So that's 10, 15, right? 5, 5, 5. However, the displacement of the frog is only 5 meters, right? Because from point G to point H, right? The displacement of the frog is only 5 meters. The height of the wall is 5 meters, right? So that is kind of the difference between a scalar and a vector. Now, vectors can be decomposed into their horizontal and vertical component. And why is that important? That is important because the projectile has a velocity, and the projectile itself, by definition, is a 2D motion. It has both a horizontal and vertical component, which means the velocity of the projectile can be decomposed into a horizontal and vertical component. And we can use trigonometry to find out the vertical velocity and the horizontal velocity. And that is what helps us use constant acceleration formulas and determine the final velocity of the projectile, the final range, the time, or anything else that is required for us to know by the question that the examiners are going to ask. So this is how a projectile looks like, basically. So it kind of travels in that inverse parabolic shape. And don't forget, there is also a range. Don't forget that because there is only a vertical acceleration, right? Acceleration due to the weight force, due to gravity. And there is no horizontal force being applied to the ball. There will only be vertical acceleration, no horizontal acceleration, which means velocity is constant in the horizontal plane, right? Because v is equal to u plus at. If a is equal to 0, v is equal to u, so v is equal to v, so it's a constant. However, for the vertical component of velocity, right, you have to use the SU-VAT formulas. The key points to remember about projectile motion is that when a projectile is in the air under the influence of gravity, the only force acting on the projectile is gravity. The horizontal and vertical forces are independent of each other. The horizontal velocity is constant, and the vertical velocity changes due to gravity, but the acceleration is constant. Hence, any of the constant acceleration formula are applicable. Does that make sense, guys? I think it's pretty straightforward. Now we're gonna go and talk about forces a bit. Just give me 1 second. I need to drink some water. And after we cover forces, before we go into fields, we're gonna do some questions because I am a big fan of practice. Practice, practice, practice. We are doing well with time. Cool, so let's keep going. Remember that forces are vectors and vectors can be added. When dealing with forces, we can use a lot of vector addition and Newton's second law. So let's review a bit of vector addition. So this is horizontal component. Sorry, vector addition is essentially something like this. So if you have, we use the head to tail method for vector addition if you guys don't remember. So the head to tail method essentially involves, let's say you have something going like that. The head to tail method involves that the force that is acting here should be something like this, the net force. I think it's pretty obvious, pretty straightforward. Now, when reviewing forces and inclined planes, we need to state that two forces act on an object on an inclined plane excluding friction. There is the weight force, the normal force, and these forces give a net force that acts downwards. These forces can be rearranged to make a triangle to find out other information about the object using trigonometry. However, please guys, do not confuse, and this is another mistake, and this is one of the things that I do talk to my students pretty often. It's the silly mistakes that a lot of people make or how they get confused on the exam, right? Inclined planes are not the same thing as banked tracks. The way you draw the forces on an inclined plane versus the way you draw the forces on a banked track are different. There is a difference between inclined planes and banked tracks. However, Vika obviously knows that a lot of students don't know the difference, and most of the time students trip up and make a mistake. So they will keep asking and asking this again. On an inclined plane, the force is acting downwards. On a banked track, which is again increased at a height in order to achieve the design speed of an object, right? The net force acts towards the center of the path. If we have time, I'll cover a bit more of that as well. During the tips. If not, yeah. It probably means that we've run out of time. However, at the moment, we seem to be doing very well with time, so let's keep going. Let's talk about tension a bit. Tension is the force in a rope or object that is created when something pulls on it. Many people struggle with tension questions, and in fact it's one of the worstly assessed topics. It's one of the worstly done the topic about tension, the questions in regards to tension are horribly answered by students, and Vika keeps asking those questions. Here are some tips to tackle tension type of questions. You always need to draw a force diagram. You need to find the acceleration of the entire system and look at the system as a whole. And once you have the acceleration, use Newton's second law to find the tension. Look at every individual component. This works for most of the time, so if you're stuck, give it a go, and also be very careful with signs and directions. Now, some tension questions, some of you might be asking, what are types of tension questions? Some of them, again, one of the mostly incorrectly answered questions on the exam, which is very simple. It's this question here. Connected bodies. Usually it's also spring kind of questions. Connected bodies is really awfully answered. As I told you guys, I've done this for a while. So, right, it's towing something. Again, these are the two main ways Vika asks or tests the topic of tension, and then the third way is by using springs. These are the three main. That's like the pattern that Vika follows to test your knowledge of tension. But yeah. That's where you need to be careful of. Remember, you can use this as a connected body. The total force, you can say, for example, to find acceleration here is the weight force acting on the object here, divided by total mass of the system, so mass 1 plus mass 2, that's the acceleration of both of them. And in order to find tension, you multiply mass here, so if this is m1 and this is m2, tension would be m2 multiplied by a, which you found here, right? So it's very straightforward, very simple. Yeah. Or I have plenty of formulas that just in case you get stuck, you can find it easily. Right, this is one of the formulas, same thing. That's how you find acceleration, m1g divided by m1 plus m2, and tension is going to be equal to same thing, but it's going to be m2 m1 plus m2g divided by m1 plus m2. It looks like a bit of nonsense here because it's a bit overcrowded, but you guys get the point. So there are plenty of formulas to double check what you're doing, and yeah, some things you can have on your cheat sheet that can help you double check your working out, essentially, because they are very quick. It's a very quick method to get to test whether you have the correct working out or not. Now we're gonna go a bit more into energy and work. I just have to say we need to take a 5-minute break now because I'm getting